Next is integer type questions. So let us discuss question number 43, in which this determinant is given to be equal to 64. So we have to find u square. So let's apply the property of determinant, that is R2 minus 2R1 and R3 as R3 minus 3R1. So we will get determinant as u plus v, u plus v plus w, and here we will get 0 u 2u plus v, and here we will get 0 3u 7u plus 3v. This is equal to 64. So we will have, expanding along column 1, we will have u into 7u square plus 3uv minus 2 6u square minus 3uv is equal to 64. That is, u cube is equal to 64, which means that u is equal to 4. So value of u square will be 16. Next is question number 44, which says that the value of summation r going from 1 to 40 minus 1 raised to the power r minus 1 into 1 plus 1 by 2 plus 1 by 3 and so on up to 1 by r 40 cr is equal to m by p. So we have to find m plus p. A little tedious question, so let's solve it. Let us write it in journal format. Let us take 40 equal to n. So we can write it equal to summation r going from 1 to n minus 1 raised to the power r minus 1 into ncr into integral from 0 to 1 plus x square and so on up to x raised to the power r minus 1 into dx. See, if you will integrate it, we will get x plus x square by 2 and so on up to x raised to the power r upon r. So putting x equal to 1, we will get it similar to the given in question. So this is equal to summation minus 1 raised to the power r minus 1 into ncr into integral from 0 to 1 minus x raised to the power r upon 1 minus x into dx, because it is a GP, right? So this is equal to, integral can be taken out, summation minus 1 raised to the power r minus 1 divided by 1 minus x into ncr minus 1 raised to the power r minus 1 into ncr into x raised to the power r into dx. Now summation r going from 1 to n minus 1 raised to the power r minus 1 into ncr, this is equal to 1, and value of minus 1 raised to the power r minus 1 into ncr into x raised to the power r is equal to 1 minus x raised to the power n. So putting it here, we will get it equal to integral from 0 to 1 minus 1 plus 1 minus x raised to the power n upon 1 minus x into dx. So that is equal to integral from 0 to 1 minus x raised to the power n minus 1 into dx, and that is equal to 1 minus x raised to the power n upon n, where limit is from 0 to 1 into minus 1, so this is equal to 1 by n, and n is equal to 40, so this is equal to 1 by 40, so this is given to be equal to m upon p, so our answer will be 41. Next is question number 45, which says that let omega be a complex cube root of unity with omega not equal to 1 and a is equal to aij, be a n cross n matrix with aij equal to omega I plus j, and n is less than 100, then the largest value of n for which a square is not equal to 0 matrix is. So let's firstly find a for 1 cross 1 matrix. So this is equal to omega square. So we can say a square is equal to not equal to 0. So let's find now a equal to 2 cross 2 matrix. So it will be omega square 1 omega. So a square will be equal to omega square 1 omega, omega square 1 omega, which is also not equal to 0 matrix. Let's now find a for 3 cross 3 matrix. That will be omega square 1 omega, 1 omega omega square, omega omega square 1. So if we find a square here, then it will be omega square 1 omega, 1 omega omega square, omega omega square 1. So we will multiply this, then we will get it equal to 0 matrix, which means that for 3 cross 3 matrix, for 6 cross 6 matrix, for all these matrices, the value will be equal to 0. So we have to find the largest value of n for which it is non-zero. So as maximum value of n is 99, so for that we have 0 matrix. For the maximum value will be n equal to 98. Next is question number 46, which says that let A is equal to 3 cross 3 matrix and I is identity matrix. So we have to find A inverse. A very simple question. We just have to put determinant of A minus lambda I equal to 0. So we will get 1 minus lambda 0 0, 1 minus lambda 0 minus 2, 4 minus lambda, determinant equal to 0. So we have expanding along column 1, 1 minus lambda into lambda minus 1 into lambda minus 4 plus 2 equal to 0. That is lambda minus 1 into lambda square minus 5 lambda plus 6 equal to 0. So expanding this, lambda cube minus 5 lambda square plus 6 lambda minus lambda square plus 5 lambda minus 6 equal to 0. That is lambda cube minus 6 lambda square plus 11 lambda minus 6 equal to 0, which means that a cube minus 6a square plus 11a minus 6i is equal to 0. Now let's multiply with a inverse. So we will get a square minus 6a plus 11i is equal to 6a inverse. So this is 1 by 6 into a square minus 6a plus 11i, which means that value of m is minus 6 and value of n is 11. So n minus m mod will be equal to 17. So answer is 17. Let's now discuss question number 47, which says that let A is equal to a matrix 3m square 1 6m, B is equal to matrix UVW, and similarly a matrix C is given where UVW and M belongs to R, and it is given that trace of AB is equal to trace of C for all M belonging to R. So we have to find the value of U square plus V square plus W square, right? So let's firstly find matrix AB. That will be equal to 3m square 1 6m multiplied with UVW. So this is equal to 3m square U, 3m square V, 3m square W. Next we have UVW, and here we will have 6m U, 6m V, 6m W. So this is our AB matrix. It's given that trace of AB, that is 3m square U, sum of diagonal elements, is equal to trace of C, that is m plus 2 whole square plus 2m plus 5m square, right? So expanding it, we will get 6m square plus 4 plus 6m. Now as these two are equal for all values of m belonging to R, so we can say coefficient of m square, m, and constant term should be equal. So we have 3u equal to 6, 6w equal to 6, and v equal to 4. So we have u equal to 2, w equal to 1, and v equal to 4. So the value of u square plus v square plus w square, that will be 4 plus 16 plus 1, that is 21. Next is question number 48, which says that let A is equal to Aij be a 3 cross 3 matrix and B equal to Bij, where Bij is equal to 2 raised to the power I plus j into Aij. For I comma j going from 1 to 3, if the determinant of A is 1 by 64, so we have to find the value of determinant of matrix B. Now let's write down determinant of B, that is equal to A11 2 raised to the power 2, A12 2 raised to the power 3, A13 2 raised to the power 4. Here we have A21, A22, A23, A31, A32, A33, and here we will get 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6. Right? Now, taking 2 raised to the power 2 common from first row, 2 raised to the power 3 common from second row, 2 raised to the power 4 common from third row. So we have A11, 2, A12, 2 raised to the power 2, A13. Similarly, A21, A31, 2, A22, 2 raised to the power 2, A23, 2, A32, 2 raised to the power 2, A33. Now again, taking 2 common from second column and 2 raised to the power 2 column from third column, so we will be left with determinant of A, which is equal to 2 raised to the power 12 divided by 64, that is equal to 64. So determinant of B is 64. Next is question number 49, which says that let S1 be the set which contains all possible values of natural numbers ABC, and S2 be the set which contains all possible values of PQR, for which A equal to a 3 cross 3 matrix is given, be a non-singular idempotent matrices. Idempotent matrix means A square is equal to A. It is given that it's a non-singular matrix, so we can take A equal to I, right? Which means that A square minus 3 is equal to 1, B square minus 8 is equal to 1, and C square minus 15 is equal to 1, and P is equal to Q is equal to R is equal to 0. So from here we get A is equal to plus minus 2, B equal to plus minus 3, and C equal to plus minus 4. So it has been given that S1 is the set which contains all possible values of natural numbers ABC. So it is 2, 3, 4. And S2 is the set which contains all possible values of PQR. So now we have to find N, that is equal to absolute value of difference of sum of all possible values of S2 minus product of all possible elements of S1, that is 2 into 3 into 4, that is 24. So its answer will be 24. Next is question number 50, which say a very sweet question from binomial theorem. So let's solve it. We have to find the value of 100C0 into 200C100 minus 100C1 into 199C100 and so on, right? So we can write it as coefficient of x raised to the power 100 in 100C0 1 plus x raised to the power 200 minus 100C1 1 plus x raised to the power 199 plus 100C2 1 plus x raised to the power 198 up till 100C100 1 plus x raised to the power 100, right? So this is equal to coefficient of x raised to the power 100 in. Now let's take 1 plus x raised to the power 100 common. So we will be left with 100C0 1 plus x raised to the power 100 minus 100C1 1 plus x raised to the power 99 and so on up till 100C100, right? Now this is equal to 1 plus x raised to the power 100 into, now this is the expansion of 1 plus x minus 1 whole raised to the power 100. This is the expansion of this, which is equal to 1 plus x raised to the power 100 into x raised to the power 100. So we have to find the coefficient of x raised to the power 100, which means we have to find constant term from this, that is 1. So answer is 1.